All right, here's quiz 7 solutions for Math 251. For the first problem, we got a couple functions and asked to find their derivatives. This first one, there's a few different ways you could do it. I guess one way, well, okay, so one way would be to take advantage of some log rules. So what I'm asking here is the natural log of something raised up to a power. So I have a log rule that allows me to take that power and put it down in front of the natural log. So this is 4 times the natural log of log base 5 of something, that something being x squared over the natural log of x cubed. So there's nothing more I can do with the natural log, but if you look inside the parentheses, what I have inside these parentheses is log base 5 of something cubed. So I can take this cubed, or this 3, and bring it down in front of the log base 5. And it's the log base 5 of a quotient. Well, I'll do that in the next step. X squared over natural log of x. And so like I was saying, it's log base 5 of a quotient of two things. So you could write that as log base 5 of the top, x squared, minus log base 5 of the bottom, natural log of x. And at some point you're going to get sick of logs and just take the derivative, but you might even go one step further and call this 4 natural log of 3 times the log, 3 times 2 log base 5 of x. So that's me taking this squared and bringing it in front of this log, minus log base 5 of the natural log of x. Close that parentheses, that one, and that one. And so now I guess we should take the derivative, f prime of x. Maybe I switch color to signify that I'm finally doing some calculus. F prime of x. Well, I say, all right, it's a constant times some function, so just leave that 4 alone and multiply that by the derivative of some huge mess. Well, this mess is the natural log of stuff. The derivative of natural log of stuff is 1 divided by that stuff. In this case, the stuff is 3 times 2 log base 5 of x minus log base 5 of the natural log of x times the derivative of all that stuff. And again, that stuff was 3 times 2 log base 5 of x minus log base 5 of the natural log of x. So this first term, I suppose I could write that as, well, a lot of different ways you could write that. Maybe 4 divided by all this stuff, 3. Well, how about this? Let's leave that first term alone for now. All this stuff times the derivative of all this stuff. Well, it's a constant times something. Pull that constant out in front. And then I have the difference of two different things. The first one is 2 log base 5 of x. Well, the 2 is just a constant. Pull that out in front. The derivative of log base 5 of x is 1 over x times the natural log of 5. And from that, I want to subtract the derivative of log base 5 of natural log of x. Well, here I'm going to have to use chain rule. So instead of the derivative being 1 over x times the natural log of 5, it's going to be 1 over natural log of x, 1 over stuff times the natural log of 5. Then I'm not done. I have to multiply this by the derivative of natural log of x, which is 1 over x. And so some mess like this would be my answer. How do you want to write it? I don't know. However you want to write it. Fine, I'll write it one more time. Let's take this 4, throw it up on top. I got 4 times 3 times 2. Right, 4 divided by 3 times 2 log base 5 of x minus log base 5 of the natural log of x. And I want to multiply that by 3 times a bunch of stuff. The first thing is 2 times all this. So 3 times 2 gives me, well, maybe I'll do this 3 times this 4. Maybe I'll just leave it as times 3. I'm going to do this 4 times this 3 and give me 12 up top here. Now I've taken care of this one. And then I'm going to say I want to multiply all that stuff times 2 over x natural log of 5 minus 1 over x natural log of x natural log of 5. Something like this. Lots of different ways you could write this. You could take this further. But I think that's more than enough on this problem. Let's call that good. Moving on. F of x equals x to the x power. Find the derivative. This is one where it's easy to get no credit on, not even partial credit, because if you try to use like the power rule or something, you can't even show me all the skills you have. Power rule doesn't apply here. This is a variable with a variable right up in the exponent. So the only way we have to take the derivative is change f of x into y. In other words, make this an implicit differentiation problem and find y prime. And the way we'll do that is we'll take the natural log of both sides of the equation. And the reason that that's helpful is I can apply a log rule to bring this x down in front and get the natural log of y equals x times the natural log of x. Let's do some calculus. The derivative of this, derivative of natural log of y is 1 over y times y prime. To find the derivative of x times the natural log of x, I'll have to use the product rule. F prime would be 1. G is natural log of x plus g prime is 1 over x times x. So this is f prime g, g prime f. So maybe from here I jump up here and say, all right, 1 over y times y prime is equal to the natural log of x plus 1, 1 being the product of 1 over x and x. So therefore, if I multiply both sides of the equation by y, I get y prime equals y times the natural log of x plus 1. Not the natural log of x plus 1, natural log of x plus 1. I don't want to leave y's in my answer because I just created this y thing. So I'll take this one step further and call this x to the x power times the natural log of x plus 1. Y prime equals this. This right here would be my answer. That's the end of this problem. Related rates gives me all this information about a tesseract, which is super interesting, at least to a nerdy math guy like me, but not all that relevant to the problem. All you need to know is that the surface volume, term you've never really heard before because you've never dealt with four-dimensional objects, is 8x cubed, where x is the length of a side. And what it tells us here is that the length of this side, length of x, is changing. It's increasing at a rate of 3. In other words, it tells us that x prime equals 3. And what it wants to know is how fast is the surface volume increasing. So the change in surface volume is what this question is asking for. And oh, by the way, the length of a side, x, is just 10. So I want to solve for the derivative of the surface volume, SV prime. I have an equation that has SV in it, but not SV prime. But I can make this SV prime by taking the derivative of both sides of this equation. I can take this equation, which is true for all tesseracts, and take the derivative of both sides to get a new equation, which tells me about the change in surface volume, not the surface volume itself. The derivative of this function over here would just be SV prime. Over here, the derivative of 8x cubed would be 8 times 3 is 24x squared. But then you're not done. You have to multiply that by x prime because x itself is a function in this problem. How do I know it's a function? Because I have a representation of the change in that function. I have x prime is equal to 3. So this equation right here tells me that the change in the surface volume is 24 times x squared, x being 10, so times 10 squared, times x prime, which is 3. Let's see, this is 100, 24 times 3 is 72, times 100 is 7,200. I don't care about your units at all. What they would be is meters to the 4th power over seconds. But I don't care about that. All I care about is that you get 7,200 something. That is the rate of change of this thing called the surface volume. It's not meters to the 4th. It's meters to the 3rd. Whatever. You don't care what the unit is, because I don't care what the unit is. Your answer is 7,200. And I guess that's finally the end of this quiz.